Welcome to Edubbey Global Solution. In our mathematics class again, we're going to be looking at the subtopic under our topic that we're looking at, which is perimeter, area, and volume. Okay, so we are going to be looking at surface area and volume under this class. We're going to be looking at surface area of some shapes like pyramid, prism, cuboid, cone, cylinders, and the likes. And we have our example related to each of them, and also we have our past question. Interactive content here is going to be serving as a guide for this class. Okay, so let's start with the first one here, which is what? The surface of a cuboid. Let's look at the shape we have there. The surface of a cuboid is the sum of the area of its faces. So, the area looks like more or less like what? Like area of a rectangle, which is what? Length times breadth. So this time around, we are going to be indicating it with width, height, and length. So the first area that we're going to be looking at here is what? The area of the top, which is W and L, which is the width and the length. So it's going to be width multiplied by length. Now the area of the bottom also is going to be what? The area of the bottom is going to be width multiplied by length as well. Okay, now the area of the front, like the front part that we are looking at here, is going to be height multiplied by the length, and the area of the back, just like we're having this structure here, which is L, and we have H here, so it's going to be height multiplied by length as well. So for this, it's going to be width multiplied by the length, and the area of the back is going to be length multiplied by the height. So by the time we add up this, it makes the area, surface area of a cuboid. So by the time we add up, we have WL plus WL plus LH plus LH. So you discover that we have 2WL, 2LH, and 2WH, right? So having that, then we can have our 2 to be common to the three of them. Then we have it 2 into bracket WL plus LH plus WH, and that gives us the surface area of our cuboid. Okay, now we are to look at these activities based on what we said the surface area of a cuboid is the sum of what? It is sum of the area of its face. Okay, so it's going to be area of its face. All right. Okay, now we want to look at the surface area of a cylinder. If you look at this cylinder, this is being split into different shapes. So we have the circle here, and we have the rectangle. We have another circle here. So that what builds a cylinder. So the surface area of a cylinder is made up of one rectangular pair, which is this, and two circular pieces. So if we have that, remember we talked about the area of a circle to be what? To be pi r square. Now, since we have two circular pieces, there is going to be pi r square multiplied by pi r square, which is 2 pi r square. Okay. Now, remember we said that the area of a rectangle is what? Length multiplied by breadth. So this time around, our length is going to be serving as the circumference of the circle, which is what? 2 pi r. Then we multiply by this, which is the breadth is h, so multiply by 8, that is 2 pi r times h. So having that, then the total surface area of a cylinder is going to be 2 pi r square plus 2 pi r h. If you look at what we have here, 2 pi r is common to them, so we bring 2 pi r outside, then we have r plus h inside the bracket, and that makes the total surface area of a cylinder. Okay, now let's look at an activities here. We are supposed to calculate the total surface area of this cuboid that we have here. Okay, so look, if you look at the cuboid, we have what? We have our width, we have our height, and we have our length and base as well. So based on the formula that we have to be what? 2 into bracket WL plus WH, okay, WH plus LH. That's the formula for calculating the total surface area of the cuboid. So if we have that, then we're going to be multiplying by each other. The first one, let's pick 2WH. 2WH is going to have 2WL rather, is going to be 2 times what? Times 7 times 10. So 7 multiplied by 10 centimeters. What is that? 7 times 10, that is, I think that is 70, then 70 times 2 will give us 140 centimeter. Okay, that's the first one we have there. Now let's look at the second one, which is what? 2 2WL, right? Okay, so we have 2, okay, let's say we have LH. Let's do that. So we have 2 multiplied by our L, which is length here, is 5 centimeter, and our H here, which is what? Is what? Is 10 centimeter, okay? Okay, 7 centimeter, right? So we are going to be having 5 times 7 is 35, 35 times 2, that is what? That is 70 centimeter. So the last one here is going to be what? 2, okay, W and L. So we have it to be 2 multiplied by 5 centimeter multiplied by the width, which is 7 centimeter. So okay, so if we have that, it's going to be 2 times 5 centimeter times 7 centimeter. Oh, we are supposed to have it to be W. We have WL, we have LH, and we are supposed to have WH. So WH is going to be what? We have it to be 10. So this is 10 centimeter. So not 5 centimeter. Since we have W multiplied by the H, so we have 2 times 5 is 10. Okay, 10 times 10 will give us 100. So we have 100. So the total surface area is going to be addition of this. So we have 140 plus 70, 140 centimeter plus 70 centimeter, okay, plus 100 centimeter. If we add 140 plus 70, that is 210 centimeter. 210 centimeter plus 70 centimeter will give us 60 centimeter. And remember, we are multiplying this. So all of these are supposed to carry centimeter square, since we are dealing with their area. So we have 210 centimeter square. So let's quickly put the solution there into the right boxes. The formula for calculating the total surface area is 2WL plus 2LH plus 2WH. And by the time we add, what is missing here? 2 times 5 times 7, that's what? That's 70 centimeter, okay? And by the time you add 140 centimeter square plus 100 centimeter square plus 70 centimeter square, then we have 310 centimeter square. And that is the total surface area of the cuboid that we have seen there, okay? Now, let's look at, we want to calculate if the height of a cylinder is 7 centimeter. Height of the cylinder is 7 centimeter. Okay. Now, and the radius of its top is what? Is 3 centimeter. We have to calculate the surface area. The formula for calculating surface area of the cylinder is 2 pi r into r plus h. Remember, we told us that pi is constant. We can take 142 or 22 over 7. That is, if you want to express it, or we leave it in the exact form. So in this scenario, we are expressing the formula. So we have it to be 2 multiplied by, let's use 3 decimal point 3.42 multiplied by the radius is what? The radius is 3 centimeter. Okay, multiplied by what is the radius here? We have 3 centimeter. Okay, and they said that the height, which is 8, is 7 centimeter. So let's add 3 plus 7 will give us 10 centimeter. Okay, multiplied by 3, that's 30. Multiplied by 3.142. Okay, multiplied by 2. So we have 2 times 30, that is 60. Okay, 60 times 3.142 will give us 188 centimeters square, and that is the total surface area of that given cylinder. So the formula is 2 pi r plus h in bracket. So by the time we multiply this, it's going to give us what? It's going to give us plus 10. Okay, 3 plus 7 is 10 centimeter, and by the time we multiply 60 centimeter times pi, we have it to be 188 centimeter square, and that is the total surface area. Okay, now let's look at another one that we have here. We have the volume and the surface area of a prism. A prism is any three-dimensional object which has a constant cross-sectional area. So if you want to calculate volume of a prism, we calculate it as area multiply area of the cross-section multiplied by what? Multiplied by length. And the surface area of a prism is calculated as the sum of area of each of the sides. So we have to calculate the sum of each area. We add them together, and that gives us the total surface area of the prism. Now let's look at the example of a prism. We have a rectangular prism here, which is cuboid. We have circular prism here, which is cylinder. We have triangular prism here that look like in a triangular shape. Okay. Now, let's look at this activity. We said that the prism is any three-dimensional object which has a constant cross-sectional area. Yeah, because if you want to calculate it, you must have your area of the cross-sectional area multiplied by height. So, which is right. Okay. Now, let's look at this activity here. We want to calculate the area of this cross-sectional area. So what we are doing here is what? We are multiplying the cross-sectional area multiplied by the length. The length here is what? 10 centimeters. If you can look at the cross-sectional area, what we can do here, see here, is this is a cylinder. It comprises of what? A rectangle and a circle. And the formula for calculating area of a circle is what? Is pi r square. So that implies that we are multiplying the area of a circle multiplied by the length. Okay, so if we have that, we have it to be the volume of the cylinder will now be and let's note the units for cylinder, the volume of the cylinder or units of any volume of a shape is rated in cube. If it is centimeter cube, we can have it in centimeter cube, we can have it in millimeter cube, meter cube, and kilometer cube. Okay, so if you have this one, then this is going to be pi r squared multiplied by L. So we have it to be, what is the pi here? The pi here is 3.142. That's what we are using. We are not using 22/7, which is the decimal expression of this. And the area, the radius here is what? That is 4. So we have 4 centimeter all square multiplied by the length, which is 10 centimeters. So if you have that, we have it to be 3.142. Okay, multiplied by 4 times 4 because we are having it all square. That is 16 centimeters square. Okay, multiplied by 10 centimeters. So 16 multiplied by 10, that is 160 centimeters square. Okay, 160 centimeters square multiplied by 3.142 will give us 503 centimeter cube. Rate this has been, expressed in 3 significant figures, and that's the solution for that question. Okay, now let's look at arc length. When you're talking about arc length, we are talking about arc length of the circle. Okay, so an arc is a part of the circumference of the circle between 2 radius. So let's use the plural form of radius is radius. So we're talking about an arc is a part of a circumference of a circle that is between 2 radii. Okay, and the length is proportional to the size of the angle, which is we refer to it as phi or theta between the 2 radii. Okay, so if you want to calculate the length of any given circle, we calculate it as theta over 360 times 2 pi r. 2 pi r is what? The circumference of the circle. Okay, so now with that, let's calculate these we have this solution here, this class activities here for us to do, which is in the circle of the length of a minor arc is 12.4 centimeter and the radius is 7 centimeter. We have to calculate, first and foremost, calculate the angle, and secondly, we are calculating the major arc, the major length of arc. So we've made mention of it that arc of length is calculated as what? Theta over 360 multiplied by the circumference, which is 2 pi r. If that is it, so we are here. They are already giving us that the r is what? Is 12.4 centimeter. And we have to look for the what? The angle, which is theta divided by 360. Okay, multiplied by 2, multiplied by 3.142. The radius is what? 7 centimeter. So having that, 360 will cross multiply to multiply 12.4 centimeters so that we can get our theta. So we have 360, okay, multiplied by 12.4 centimeter equals to theta multiplied by 2 multiplied by this is multiplication 3.142 multiplied by 7. We want to get our theta, so we divide this side by this multiplication and divide the other side by the multiplication. So having that, we have divide times 3.142 times 7. We divide the other side by 3.142 times 7. So this we cancel this. Now we are even having that, we have theta left here. Okay, so what we need to do is what? We multiply 360 times 12.4, and that is that. That is what? That is 464 centimeters. That is 4,464 centimeters. Then the next thing for us to do is we still have 2 here. Okay, so we are multiplying 2 times 3.142 times 7. So if we have that, we have 43.988 centimeter. So by the time we divide 43.988 centimeter by 4464, then answer is going to be 101. So theta will give us 101.48. So if we approximate that, it's going to be 101.5 degree. Since we are dealing with what theta, so we have to put it in degree. Now the second one says that we should calculate what? Calculate the major arc and the minor arc. So before we do that, we have to calculate the circumference of that circle, and we subtract it from the what? The minor arc that has been given. So the circumference of the circle is what? 2 pi r. So we multiply that, it's going to be 2 multiplied by 3.142 multiplied by 7, which is the radius, and that will give us 44.0 centimeters. So to calculate the major arc now, major arc will now be 44.0 centimeter minus 12.4 centimeter, and that will give us what? That will give us 31.6 centimeter, and that's the solution for that given question. Okay, so now let's look at the next question that we have here. But before we go to the question, we have area of a sector. So a sector is the region of a circle enclosed by 2 radii and an arc, like we had in the previous slide, which is for arc, that is with the circumference of a circle, but for a sector is a region of a circle, and it is being enclosed by 2 radii as well and an arc, and its area is proportional to the size of the angle theta between the 2 radii. Now, for us to calculate area of a sector, we calculate it as theta over 360 multiplied by area of a circle, which is what? Pi r square. So we have an example here. Let's look at it. This is the file in the sector, and we have an example here. We have our theta to be 45 degree, okay, and we have our radius to be 12 centimeter. We have to calculate the area of that sector. So we employ the formula, which is what? A equals to theta over 360 degree multiplied by pi r square. So theta here is what? Theta is 45 divided by 360, okay, multiplied by 3.42 multiplied by r square. That is 7 centimeters square. So if we have that, 45 divided by 360 will give us 0.125, okay, multiplied by 3.142 multiplied by 7 raised to power 2 will give us 49 centimeters square. So by the time we multiply that, then we are going to be having an answer to be 0.125, okay, times 3.142 times 49. So our answer is going to be 19.245 centimeters. So if we are in centimeters square, we are dealing with area. So if we have to approximate that to 3 significant figures, it's going to be 19.3 centimeters square. And that gives us the solution to that given problem. Okay, now let's look at the volume of a sphere. To calculate the volume of a sphere, the formula is 4 over 3 by r cubed. And for the surface area of a sphere is calculated as 4 pi r square. So we have a question here. We have to calculate the volume of this given sphere. For this sphere, the radius is what? Is 3 centimeters. And based on the formula that we have, that the volume of a sphere is calculated as 4 over 3 by r raised to power 3. So all we just need to do is express our pi and our radius. So we have 4 over 3, okay, multiplied by 3.142, okay, multiplied by 3 raised to power 3. 3 raised to power 3 is what? That is 3 times 3 times 3, which is what? Which is 27, isn't it? Okay, so multiply by 27. So we can easily cancel out. 3 can go in this. We have 3 in 27, that is 9. So what we have next is 4 multiplied by 3.142, okay, multiplied by 9. So if we have that, our answer is going to be 113.112 centimeter cube. Why are we written in cube? Because we are dealing with volume. So if we approximate it to 3 significant figures, it's going to be 1. This is 3 decimal places. So if we have it in 3 significant figures, it's going to be 113.1 centimeter cube. And that is the solution for that given question. Okay. Now let's look at the volume of a pyramid. A pyramid is a three-dimensional shape in which each of its face must be plane. So that is true. For a pyramid to take place, then each of its dimensional shape must be okay plane. Now they will look at this. They say that we have a plane shape here for the square base pyramid, and we have for the hexagon base pyramid. Hexagon means 6, right? So it's going to be having 6 angles rather, and this is going to be having 4 angles. So you have a plane shape here. Okay, so a pyramid has a polygon for its base, and the other faces are triangle with a common vertex called apex. So the common vertices are actually called apex, and if you look at it, this is a triangle, a triangle, a triangle. So if you look at this, for this hexagon base pyramid, we are going to have 6 triangles, and for this square base pyramid, we are going to have 4 triangles. So the volume of a pyramid is calculated as 1/3 multiplied by base area multiplied by perpendicular height. Now we want to calculate the area of this given pyramid that we have here. Okay, so look at the pyramid. We have a rectangular shape and we have a surface to be what? To be plane. Okay, so a rectangular base pyramid has a perpendicular height of 5 centimeters and base dimension as shown. So we have to calculate what? Calculate the volume of the pyramid. Remember we said that to calculate the volume of the pyramid, we have to multiply. It's going to be 1/3 multiplied by base, okay, base area, okay, multiplied by what? Perpendicular height. Let's denote that as h. So under this aspect, the perpendicular height is what? Is 5, and the base area is what? 3 and 7. So it's going to be 1/3 multiplied by 3 centimeter multiplied by 7 centimeter multiplied by 5 centimeter. So easily 3 can cancel 3 here. So we have 3 centimeter multiplied by 5 centimeter length. Okay, so if we have that, that is 7 times 5 will give us what? That is 35 centimeter. But remember, we are dealing with volume, so we rate it in centimeter cube. Okay, so and that gives us the solution to that given problem. So let's drag in half times base area times perpendicular height is the formula, and by the time we multiply this, we have 1/3 times 3 times 7 times 5 centimeter. That's 1/5 divided by 3, and that will give us 35 centimeter cube. Okay, and the next one we are looking at here is the surface area of a pyramid. The surface area of a pyramid is found simply by adding together the areas of its surface. We have a plane surface, so if you want to get the surface area of a pyramid, all we need to do is what? We add up the sum up together the area of its face. Okay, now volume of a cone. A cone is a pyramid with a circular base. If you look at this, see the base here is circular, right? So that makes a cone. Something like when you are measuring in mold of a given commodity. I'm just citing an example of the cone, right? So for us to calculate the volume of a cone, we said that it is 1/3 multiplied by base area times I, which is 1/3 by r square times height. Now, if that is the case, we have a cone here, we have to calculate the area. If you look at this, the radius here is given as 4 centimeter, and the height here is what? Is 8 centimeters. So based on the formula that we have, which is 1/3 by r square multiplied by what? Height. That's the volume for a cone. So we have it to be 1/3 multiplied by, let's say, 3.142. We are expressing the decimal point of the pi. By what the radius is 4 centimeters, so we have 1 centimeter square multiplied by 8 centimeters. So we have it to be 1 times 3.142 times 4 times 4 is 16 centimeters square. Okay, times what? We have it times 8 centimeters, all divided by 3. So if we have that, we have 3.142 multiplied by 16 multiplied by 8 to give us 402.176 centimeter cube divided by 3. So dividing that by 3, we have an answer to be 134.05867. So if you want to approximate that to one decimal place, it's going to be 134.05867. 5 turns to 1, so we have 134.1 centimeter cube, and that gives us the solution to that given problem. Now let's look at the surface area of a cone. The surface area of a cone is comprises of the area of the circular base and the area of the curved face. So the area of the curved face is equal to the area of the sector from which it is formed, which is the true, and that's the way at which we can calculate the surface area of our cone. Now we want to look at the next slide, which is a past question. The diagram shows a sector of a circle of radius 8 centimeter. Okay, the length of an arc is 6.4 centimeter. Okay, then we have to calculate what? We have to calculate the area of the sector. So first and foremost, what we need to do here is we have to calculate the length of an arc, and after we are done getting the length of an arc, then we can now calculate the area of the sector. So the length of an arc is calculated as theta over 360 multiplied by 2 pi r. Okay, so here we are told that the length is 6.4 centimeter. Okay, so we don't know the theta, so we are divided by 360 multiplied by 2 times 3.142 multiplied by our radius is what? 8 centimeter. Now having that 360 we multiply 6.21, then we have our theta there. So we have 6.24 centimeter multiplied by 360 equals to theta multiplied by 2 times 2.142 times 8 centimeter. So if you want to get that, we divide both sides by 2 times 3.142 times 8 centimeter, so that we can have our theta left here. So we have 2 times 3.142 times 8 centimeter on this side. Then we divide the other side by 2 times 3.142 times 8 centimeter. So these 2.3 for 1.2 will cancel each other here, so we have theta left here. So 6.4 multiplied by 360, that will give us 2,304 centimeter, and 2.3.42 times 8 centimeter will give us 50.29 centimeter. Having that, 50.29 centimeter can actually go in 2,340 centimeter in 4.58. Now remember, we are dealing with theta, so we rate our answer as degree. Now we have gotten our theta. The next thing for us to calculate now is what? The area of the sector. So we have area of the sector to be what? The formula is theta over 360, okay, multiplied by the area of the circle, which is pi r squared. So now we have gotten our theta to be what? So theta is already 45.8 multiplied by 3.142 multiplied by 8 centimeter all square. That is the radius, right? So we have it to be A equals to 45.8 multiplied by 3.142 multiplied by 8 times 8. Since we are dealing with square here, that is 64 centimeter square. So having that, remember we are dividing this by 360, okay? We are dividing by 360. So A equals to now 4.58 divided by 360 will give us 0.1272, okay, multiplied by 3.142 multiplied by 64 centimeter square. Now A, which is the area of the sector, will now give us 25.8 centimeter square, and that is the area of the sector. This takes us to the end of our class. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you.